Hello, Geometry. This lesson is titled Special Right Triangles. Well, there's two special right triangles we're going to be dealing with. The first one is a 45-45-90 triangle, and the other is going to be a 30-60-90 triangle. Well, first we have the 45-45-90 triangle. And here we have this theorem. In a 45-45-90, talking about their degrees, triangle, both legs are congruent, and the length of the hypotenuse in this case is blank times the length of a leg. Well, we're going to do the work here to prove what goes in that blank. Again, now this is an isosceles right triangle because we have the 45 and the 45, as you see here. So, we've learned the Pythagorean theorem. So if we wanted to find the length of the hypotenuse, we could say the side, this isn't writing well to begin with. It's not a good start. Okay. We have side squared plus side squared is equal to, in this case, just for this example, well, I'll just do the first side. We'll call this the hypotenuse squared. So one side squared plus one side squared will be two sides squared. And that's equal to the hypotenuse squared. Now again, we always want to square root to get rid of a square. Now if we square rooted this where it's at, the square root of s squared is s, but we still have that root 2 underneath. We can't take that 2 out. And that's what the hypotenuse is equal to. So here we have s times root 2. Okay? So, again, with our theorem here, both legs are congruent, and the length of the hypotenuse is root 2 times the length of a leg. Okay? Let's see if I can make that a little neater here. So we have root 2 times the length of a leg. So this is our formula we're going to use. The hypotenuse is equal to the leg times the square root of 2. Okay, well that makes these problems actually quite easy if you know the side lengths, because then you multiply it by root 2 to find the hypotenuse. So in this instance, it says find the value of each variable. Well, again, this is an isosceles right triangle. That means if this leg on the right is 5, that means this leg up top, again, the other side making the right angle, would be 5 as well. Well, now that we have our formula, it says, again up here, you just take whatever your leg value is, times it by root 2. So in this case, m would just equal 5 root 2. It's that simple. So there goes your hypotenuse. Now on this one, it says one side, or one leg, is 6 root 2. So again, the other one also is going to be 6 root 2. Now you have to be careful on a problem that already has a root there for you. Okay? Because the formula says take your side length, in this case, your leg, which is 6 root 2, and multiply it by root 2. Well, here we have 6 root 2 times root 2. Now, if we were to multiply these two first, we would have 6 times the square root of 4. Well, what is the square root of 4? The square root of 4 is 2. So, therefore, we get 6 times 2 is 12. So, B would equal 12. So, again, when the legs already have a root 2 in it, you still have to stick with the formula. You have to multiply that value by root 2. Okay? So again, that would be our hypotenuse. Okay, let's move on. Here it says find the length of the hypotenuse of a 45-45-90 triangle with the legs of length 8 root 3. So we have some triangle here. It's a right triangle, and these are both 45 degrees, and that's going to be 45 degrees. It says that's a right angle. And it says the leg has 8 root 3. Well, that means the other leg also will be 8 root 3. Now, if you're trying to find the hypotenuse, let's call that h for hypotenuse. It says take one of the legs, in this case 8 root 3, and we're going to multiply it by root 2. Now, you're not allowed to add and subtract roots that have different numbers underneath the root, but you're allowed to multiply. So again, root 3 times root 2 is root 6, and we still have the 8 to bring down. Now you can't break down 6, so that's your answer. Your hypotenuse is just 8 root 6. There you go. Again, take your leg, multiply it by root 2. It's that basic, that simple. Now, notice on those examples, we knew the leg, the value of the leg, the length of the leg, and we were trying to find the hypotenuse. Here it says, what happens if you know the hypotenuse, but need to find the length of the sides? Well, if our formula is hypotenuse is equal to the leg times root 2, then if we wanted to, in this formula, get the leg by itself, we would divide both sides by root 2. Notice again, we would divide this by root 2 to cancel out, which we're allowed to do as long as we divide this side by root 2, which then gives us this formula right here. You take your hypotenuse and divide it by root 2. Okay, so therefore, here in this problem, what is the value of x? Well, you take your hypotenuse, and it says divide this by root 2. Now, at some point back in algebra, you probably learned about simplifying radicals, getting radicals out of the denominator. Okay? Well, as a recap, just in case you didn't, you're not allowed to leave a root in a denominator. And that's not proper notation. So we have to get that root out of the denominator, and the way we do that is to multiply that denominator by itself. But you're not allowed to do that in a math problem. You can't just multiply a denominator by a number unless you're going to multiply the numerator by the same value. So therefore it evens it out. So now, when we multiply across, 8 times root 2 gives us 8 root 2. Root 2 times root 2. We said before that's root 4, and the square root of 4 is 2. And you always want to see if you can reduce. Well, here we have 8 over 2, which 8 divided by 2 is 4. But that root 2 stays there. So therefore, we know that each leg is going to be 4 root 2. Okay? Again, we took our hypotenuse, we divided it by root 2, but then we had to simplify the radical by, we had to rationalize the denominator by getting the root out of the denominator. So we multiplied it by itself. Because root 2 times root 2 is 2. Okay? And then we divided. That reduced 8 over 2. Again, that's what you call rationalizing the denominator. So let's try one more example here. Find the length of a leg of a 45, 45, 90 triangle with a hypotenuse of 14. So we have some 45, 45, 90. That's 45, 45, 90, in which the hypotenuse is 14. The same procedure takes place. We have our hypotenuse, we divide it by root 2. Can't have a root 2 down there. So we have to multiply by itself. Therefore, we have to multiply the top by that same value. So you have 14 times root 2 gives us 14 root 2. And as you multiply across, root 2 times root 2 is the square root of 4, which is 2. Okay? And now you do division. See if you can reduce 14 over 2. 14 divided by 2 is 7 root 2. Now I'm not sure if you noticed the pattern here. There is a shortcut pattern. Whatever your hypotenuse is, you cut that value in half and times it by root 2. Okay? Notice this was a 14. Cut that value in half and then times it by root 2. So that would give us 7 root 2. It's a little shortcut as well. Back up here, notice that was an 8. Cut it in half, you get 4, but times it by root 2. Okay, that's a little shortcut for you if you know the hypotenuse and you're looking for a leg. Okay. Well, let's put this into practice here with a word problem. In professional baseball, which is a wonderful sport, go Giants, the base path is in the shape of a square. So we have here a horrible shaped square. That looks terrible. So sorry. So let's just do this. It's not that much better. Anyways, we have here in baseball what we like to call a diamond, but it's in the shape of a square for the base path. The distance from base to base is 90 feet. So if this is home plate, we'll do a little H for home plate. That's 90 feet. That means they're all 90 feet because it is a square. All right. To the nearest foot, how far does a catcher throw a ball from home plate to second base? Now, I'm sure you all do, that you all know, but just in case, this is first base, this is second base, this is third base, and that down there is home. So how far does a catcher throw a ball from home plate straight across to second base? Okay? Well, that's the question. Well, notice here, we can actually cut off this whole left side. And notice what shape we have. We have here, what's left with for us is a right triangle. And more specifically, since the top and bottom were right angles and we just bisected them, that means we have a 45, 45, 90 triangle. Well, what you do is you have 90, and 90 are the legs. So if you know the legs, you just multiply it by root 2 to find your hypotenuse. But the thing is, if you actually ask someone, how far is it from home plate to second base, you're not going to say it's 90 root 2 feet. What you're going to do is you're going to calculate that and go to the nearest foot. Okay? So if you type that into your calculator, 90 times the square root of 2 to the nearest foot, you should end up with about 127 feet. So a catcher is going to have to throw the ball 127 feet to second base. Okay? But again, this is how we get to use 45, 45, 90 triangles in a real situation. All right, let's move on. Let's do one more of these. Then we'll move on to 30, 60, 90. A square garden. Always look for keywords in word problems. A square garden. A square garden has sides of 50 feet long. Okay, so all sides are 50 feet. That is a 0, not a 6. Don't want you to get confused with that. You want to build a brick path along a diagonal of the square. So here you have this brick path going straight across. And again, since these are all right angles, that diagonal is going to bisect the angles it's touching, making a 45, 45, 90 triangle. Actually, two of them. So it says, how long will the path be? Again, the shortcut, if you already know the lengths of the legs, you just multiply that number by root 2, and it'll give you the hypotenuse. So then we go to our calculator, and we calculate, and we end up to the nearest tenth, 70.7 feet. Again, that is if you are going to round to the nearest tenth. Because again, you're not going to tell someone that your pathway is 50 root 2 feet. You're going to say it's it's about 70.7 feet long. Okay? So when you're actually dealing with word problems, you are probably going to be plugging that root into the calculator to get one number for your answer. Okay? So that's how we deal with the 45, 45, 90. Now let's look at the 30, 60, 90 triangle. The 30, 60, 90 triangle theorem. In a 30, 60, 90 triangle, the length of the hypotenuse is... Now I'm just going to give you the fill-in answers here. The length of the hypotenuse is... I don't think I left myself enough room. Twice the length of the shorter leg. Okay? The hypotenuse is twice the length of the shorter leg, the side that's opposite the 30 degrees. The length of the longer leg is root 3 times the length of the shorter leg. And again, it's all depicted there in that picture right there. The hypotenuse is twice the shorter leg, and then the longer leg is root 3 times the shorter leg. Okay? So now we get to use those ratios right there to find values of 30, 60, 90 triangles. It says find the value of each variable. Well, if you know your hypotenuse on a 30, 60, 90, and again, notice up here, hypotenuse is twice the shorter leg. So, hypotenuse 10 is equal to twice the shorter leg, shorter being x. Therefore, we just cut it in half. X will be 5. Okay? The shorter leg is half of the hypotenuse. Now we still need to find y. But again, with our formula, the longer leg is whatever the shorter leg is times root 3. So our shorter leg is 5 times root 3, and there you go. Now if you want me to go ahead and prove that that actually works, if you did the Pythagorean theorem, you would get 5 squared plus 5 root 3 squared. Does that equal 10 squared? Well, in this case, you have 25 plus, now here's a little tricky part, you have to square both of these. So 5 squared is 25 times root 3 squared, which is just 3, is equal to 100. Well, again, you have 25 plus 25 times 3 gives us 75, which, notice, 25 plus 75 is equal to 100. So just to show that it works, that ratio does work. Again, the hypotenuse, if you know the hypotenuse, cut it in half to find the shorter side. Once you know the shorter side, you times that value by root 3 to find the longer, I say the longer leg, not the longer side, but the longer leg. Okay? So let's do another one of those. Oh, I thought I had another one of those, but we'll talk about one other thing here. Now, what happens if you know the longer leg? Okay, if you know the longer leg, it says here, to find the shorter, you divide that longer leg by root 3. Therefore, find the value of each variable. Okay. Now, notice here we know opposite the 60, that's the longer leg. To find the shorter one, what we're going to end up doing is taking the longer leg and dividing it by root 3. But just like we did on the 45, 45, 90 triangles, we can't leave that root 3 in the denominator. We have to rationalize the denominator. And the way we do that is by multiplying it by itself. So multiply by root 3, which you're allowed to do only if you also multiply the top by that value. So here we end up with 5 times root 3, which is 5 root 3. In the bottom we have root 3 times root 3, which is the square root of 9, which is 3. Now here nothing reduces, so that's just our answer. So our short leg is 5 root 3 over 3. Okay? But we still have to find the hypotenuse. But again, the hypotenuse, well, let's call it x. In this problem, the hypotenuse is equal to the shorter leg times 2. Okay, whatever the shorter leg is times 2. Well, what's 2 times 5? 10. And we still have the root 3 on top, and we still have that 3 on bottom. So that is what x would equal. That's what the hypotenuse would equal on this problem. Okay? So that's how we work these problems. I wish you well with these. Again, stick to these formulas. The ones like right here at the very top of this page. Okay? The formula is right here with the triangle, the 30, 60, 90 triangle theorem, and also on the first part with the 45, 45, 90 triangle theorem. Stick to these formulas, and you should do well. Good luck.